Welcome to N is for Networking. I'm Ethan Banks with Holly Metlitsky. I'm the guy hiding his bald head and permanently furrowed brow under a dad hat, while Holly is still full of youthful packet vitality, dreaming of switches as she goes to sleep each night. Now, whether you're prepping for a networking certification or learning about the industry so you can be awesome at your job, we've got something for you. Send your comments, questions, and actuallys to packetpushers.net/follow-up. We know a bunch of senior network engineers listen to this show, so feel free to improve on anything we get wrong via a follow-up message. And we hope we don't make a lot of mistakes. But if we do want to hear about them. And by the way, we are planning a actually show for the near future where we're going to go over several of your comments that have come in. You can follow Holly and me on LinkedIn and chat with us in the Packet Pushers community Slack group, and please do. In today's episode, Holly, we're going to continue this open shortest path first OSPF routing protocol discussion, but this is going to be the last one for a while. I think after this one, we'll have covered the basics. So today, we're going to do this overview of OSPF area types. When you've been telling me you're just so excited about this, you just really are looking forward to this topic. You're so keen.
I'm so passionate about it. I really love OSPF areas.
So for those of you that are out there as a CCNA student, you don't have to know about this. You can skip this episode if the only reason you listen is just because you're working on CCNA. I looked at the CCNA blueprint from Cisco. You don't have to know area types. They don't get into it. Now, if you're working on a professional level cert, you do need to know your OSPF area types. Isn't that right, Holly? Because you're working on your JNCIP and you run into this, right?
Yeah, and I've run into it from not these are all the different area types, but we're going to go through every single OSPF LSA, and we're just assuming that you understand all the areas. But
because that kind of goes hand in hand, I guess.
Yeah, I don't work with OSPF areas. So now I've got to learn the LSAs, but I need to go back and record this episode.
I mean, you do by definition work with OSPF areas in the sense that you have to have an area, at least an area, one area.
Yeah.
But they don't, I mean, if you're only working with one area, you're just using it as a standard area or the backbone area. You're not using any of these weird, totally not so stubby area types or whatever. You haven't picked anything like that. Is that your point?
Yes.
Okay, well, all right. This isn't as hard. Everybody says this. It isn't as hard as it sounds. It is a little confusing because the terminology does overlap a bit. So you're like, wait, what's the difference between a stubby area and a not so stubby area? And then a totally, wait, what? But
they weren't very creative with their naming.
No, but when you start looking at it, then it's like, oh, okay, I see what they did there. So we're going to get into it. But before that, I want a little background for us. What is the point of different area types? Did you get a sense of that, Holly, as you've been digging through this?
Yeah, that I get. So the point historically is to try and reduce your route table size. So if you've just got one area, you're going to have hundreds, maybe thousands of routes all coming in. If you land up, or what you can do is you can split that area into multiple areas, and through summarization and other methods, you can then reduce the load on those routers. Mm-hmm. But do we need to do that?
I mean, right. And see, really the implication here is historically this mattered when Ethan was working on an OSPF network 30-something years ago. One of the first networks I worked on, that was a network of some size. We cared about this stuff because it's like, I got this little bitty WAN router sitting way out there at the edge of this network. And they're like a small office. They have one subnet, and the only way out of their network is that router. Why would I send them a full routing table with thousands of routes from the rest of this great big network we're working on and ask the router to keep up with all the SPF calculations every time something changes? And I wouldn't do that. So I'm going to put that router, that little WAN router out at the edge of their little office, in its own area and make it a stub area of some flavor, of some kind. And then it doesn't have much to do by comparison to one of the bigger honking OSPF routers that we might have as a backbone router that's going to sit there and deal with all the churn that we might have experienced, which there was a decent amount of churn back in the day, especially with telco circuits and stuff. DSL circuits, and sometimes we had dial-up circuits. It's embarrassing to say, but that was a thing. We have dial-up like ISDN circuits that would come up, and then we don't need it anymore, and then it would go down because money. You'd save money on stuff like that. It's just a totally different world now. So again, historically, it mattered. You thought a lot about what OSPF areas and area types you would segment your network into, because you had routers with limited resources and you had to care. It was a thing that mattered. The only other way you could solve would be put a big honking router everywhere. And there were some shops that did that. It's like, we only buy, like back in the day, it would have been like a Cisco 3000 series router or something like that. And that's great if you got the money. Yeah. Where I worked, we didn't have that money. It was a government network, and we were all like, everything was beholden to the taxpayer. And it's like every dollar was scrutinized, and we got limited budgets. So it's like, we're buying the little teeny guys where we had to, and the big guys where we had to, and we couldn't standardize on like big honking routers everywhere. So fair. I mean, you get the history of it.
That's fair.
Yeah. So I guess another way to think about it would be, why would you need a full routing table coming in from area 0 if everything has to go through area 0 anyway? So that is, why if I need a full routing, I need a full routing table on a router. If I got a bunch of different ways I might get to one of those destinations, then a full routing table is exciting to me. But if the only way I have to get between my network and the rest of the network is through this one path, like I was describing, that little office that's got one WAN router, why do I need to send all the routes up to the little WAN router? I could send a default route or a summarized route of some kind, and that's, everything you need to know, because it doesn't matter. The answer to the question of how do I get from this network to everywhere else is go that way. That's it. You only got the one choice. What's the point of sending a whole bunch of routes down the line? Would be another way to think about it. So, okay. So the term autonomous system comes up again too when we talk about areas and stuff like that. I just wanted to see if that had crossed you. Oh, you're making faces.
I think I might have complained about this in a previous episode.
You did. This is why I'm asking you if you noticed autonomous system come up in OSPF, because you were mad about how they're talking about it in BGP.
I did. And there was a diagram, and it said autonomous system. I'm like, oh, BGP network. No, OSPF.
Right.
Thank you.
And that's another term that comes up when you're dealing with OSPF areas, area types, and the different LSAs. You deal with something called an autonomous system boundary router, which can sit at the edge of an OSPF area and inject routes from that other autonomous system. So all of the OSPF network, that's an autonomous system. And whatever this other network is, that's an autonomous system. And you've got this ASBR, autonomous system boundary router, in the middle, sitting at the edge of a particular OSPF area. And depending on the OSPF area type, how that autonomous system boundary router behaves is affected. And I just was curious if you'd run up against the term, because I was trying to tell you, it's not just a BGP thing. It sounds like a BGP thing, but and that's where we used it most often, but it isn't exclusively.
I think it's more, not maybe useful is not the right word, but it does have a much bigger purpose in BGP than it does in OSPF. Like, you come across it in OSPF, but it's not, the routing protocol is not dependent so much on that AS, that autonomous system number, whereas BGP, it's really, really important. So
exactly, yeah.
You associate, when one day we get to BGP, you'll understand that why in my head, AS is synonymous or not synonymous, but it's linked to BGP. I don't even think about it with OSPF. So now I need to
I know.
Go backwards.
I know. And OSPF does not have a routing concept around an autonomous system as such, like we do with BGP. With BGP, the way the routing is done is so vast, it's internet scale, it's global scale, that we hop through autonomous systems as opposed to individual routers from a standpoint of computing best path. your AS path hop count is really key to BGP and not a thing in OSPF. OSPF does not think about how to compute paths based on autonomous systems whatsoever. So,
This might be a question that you might not have the answer to right now. I'm not sure. But in an OSPF packet, is that autonomous system tagged anywhere? Is there anywhere where you can see, oh, this packet has come from this OSPF autonomous system? Or is it just we know that there's an autonomous system?
I mean, I won't say definitively no, but not that I can think of. One of my concerns is there's been a lot of, beyond the core OSPF stuff that gets taught for certifications, there's been a lot of OSPF drafts that have come up later. And I don't believe, and I certainly don't know every single one of those drafts and what tweaks might have been made to OSPF as a protocol, but I don't think so. Even if, like with BGP, if you fire up a BGP process, usually it's tied to the autonomous system number that BGP is running within. With OSPF, you've got a process ID. You can start multiple OSPF processes, but that doesn't mean there's no such concept as a globally significant OSPF autonomous system number. That's for sure. I think the closest thing we might have is a process ID, and even that's not an autonomous system, because you can fire up an OSPF process ID 1 on, like, I'm thinking Cisco stuff because that's the command line I know the best. You can have that process ID be one number on one box, have the process ID be something different on a different box, and that's fine. They can still participate in the same OSPF autonomous system, since that's what we're talking about, and you'd never know the difference. So yeah, and actually that's some OSPF fun and games you can play. Hey, am I actually dealing with two different link state databases if I start a router OSPF 1 and a router OSPF 2 in the same box? And that, I haven't tried that in the lab in a while to know what's gone on there. In theory, you could. Oh boy, Holly, you asked great questions. That's a fun one. Okay. So a couple other points I wanted to make here before we dive in a little deeper. This notion of the small office with the single WAN router, right? And I was arguing, why do I need to send the whole routing table in there if the only way out is the one way? So just send a default route that covers everything and make that router's job easier. Well, what if I had two routers at the edge, because redundancy? And you might do that. You might spend money on a redundant router and circuit. What do you do then? And then now you can, you got to think about what you're actually looking for from your network's behavior. Do I want to load balance traffic across those two links? Where do those two links that are dual homing that office go to? Maybe in that case, it's a dumb idea to send default routes only. You could send two different default routes and just announce two different default routes with the same cost and kind of load balance between them. Or maybe one of those circuits goes to one headquarters location and one of those circuits goes to a different headquarters location. And so you actually want to announce full routes into that router because it matters which link you take. So it's not always like, obviously, I'm going to summarize everything behind a default route. There is thoughtful design that needs to go into whatever it is that you're designing. And this can happen with BGP too. If I'm an enterprise and I get a BGP connection to my internet service provider, I have an option. I can ask them, send me full routes. That is, I want the entire internet routing table. Okay, that's a lot of routes. That's like, I don't even know what the latest number is. It's like 1 million now, isn't it? I don't know if you've run into this in your...
Yeah, it's large.
Yeah, it's big. It's a lot. And the BGP routing table on the internet never converges, meaning that router that's listening to that full BGP feed is in a constant state of churn. It's always having to do calculations to figure out best path to where it's going to go next. But if you've only got one path out of your enterprise to your ISP, why would you take a full routing table from your ISP when you could just do a default route? That's another option. You could just send me a default route. I don't need to know. But and like I've designed internet connectivity for some enterprises like this, where we'll have 2 or maybe more feeds, and I'll announce my BGP route to them, and I'll say, send me full routing tables on your links, and then I make my BGP routers sort it out. Like, okay, I got this full tables coming here, these coming here, and these coming here from this third feed, and I need BGP to work in that case, so I need to determine router A, B, or C, which is the most efficient way to get to whatever the destination is. I say all that just to make the point. Sometimes it's dumb to take full routes because you only got the one path. And OSPF areas can actually help us with this. You have to have an OSPF area and an ABR, an area border router, to accomplish this. BGP, it's kind of the same thing. It's like, if you have multiple ways to get to the internet, you probably want to take full routes so that you can load balance across those different links. As in, there's no one right answer. It depends. You got to think about it. I know that's part of your job. That's what you do with customers. You help them figure this stuff out. But anyway. All right. So I'm going to ask you this question, because I know we've brought this up before, but I mean, do you see multi-area OSPF in 2025? You've kind of told me almost never, right?
Yeah, I haven't come across it at all yet. Okay. I mean, it's not like I've dealt with every customer or network under the sun, but I've been looking at them for 2 years now, and I have not come across it outside of a textbook.
And to me, the reason for that is because control plane CPUs have gotten a lot more powerful. I know it might have been 10 years ago. I remember recording a podcast with a bunch of nerds and enterprise people and they're all OSPF people for sure, but then service provider people. And the discussion was, do you need multi-area in whatever the year was? It was the 20-teens probably that we recorded that. And by the end of that conversation, I mean, we kicked it around, but the answer was no. Not really. And all of us had grown up in the era of, we all had a Cisco background on some level. And Cisco had a rule of thumb back in the day of like 50 routers in an area and no more. That's it. If you go more than 50, man, that's too many. It's just, it's bad. And now it's like, whatever, just do the thing. And yeah, circuits will go up and down and routers will reboot and things will change. And OSPF will have to do SPF calculations periodically. Fine. The CPUs these days can handle that fine. So I don't see multi-area as a gotta protect the routers, gotta make the network design come in for a budget, and so on. It's more of like, well, do I have a design requirement that makes me need areas? Because there's things I can do in an ABR that I can't really do anywhere else. That's the thing. And this is where I want you to keep an open mind, because you're like, I don't like areas. I don't need them. Yeah, okay, fair. And you're right. But with OSPF, if I want to do things like filter routes, or I would like to summarize routes for a reason, I can't do that within an area. I can only do that inter-area. I can't do that intra-area. And so maybe there's a network design requirement that pops up where you care. Maybe. Just an open mind.
And I'll look for an alternative.
Maybe OSPF's the wrong protocol in this case.
I like OSPF. It's one of my favorites. I get it. I understand the need. I understand the use case. I would like to avoid learning it just for certs. I think that's really what my qualm is. My qualm is, there's so much content and so many things you need to know, and sometimes it's tough as somebody without you coming in. You want to get a cert, you want to do your CCNA, but you don't have experience in the field. You don't know that OSPF areas aren't really a thing in 2025. So maybe you find this a little bit challenging to understand or wrap your head around. You spend so much time wrapping your head around these things, and then you go into the real world and you never touch it. I'm like, I feel like there should be a disclaimer, like, this is good to know, but maybe not so much for modern day networks. And then I'd be happy. But then I'd also skip the chapter probably, so maybe not.
Yeah, you gotta... So the point of, I don't want to have to know this just for my certification exam.
Like, I want real world knowledge that... Because my brain can only keep so much.
this is my point about keeping an open mind.
Mm-hmm.
Where it comes in is not what I would have thought of as the most important historical reasons, but that network design, element. Knowing what the different areas are and how you might use them to accomplish a particular network design gets interesting.
Mm-hmm.
And one of the big things to me relates to security.
Yeah.
I can't filter routes within an area. I can't do it because we talked about this in one of the earlier OSPF episodes. Every link state database within an OSPF area has got to be identical, right? They all have to run the SPF calculation from their own point of view. But if their LSDBs are not identical, they're going to compute different routes through the network. So they got to be identical, meaning you can't just filter a route and take it out and stop announcing it. You can announce it, with some routers, but not others. You can't do that kind of thing. Meaning you can suppress a route on one router and the other 6 routers in the area, boop, boop, that route's going to show up, which drives you nuts. If you're a person who I don't want this route to show up anywhere, it's like a whack-a-mole trying to get the thing to go away.
And that makes a lot of sense because there are definitely some routes that you don't want to be announced throughout your entire network. So
there are, exactly. And there's other ways to solve the problem too with filters and so on. Dismissing the route from the routing table certainly isn't the only way to go about it. And we use access lists for a lot of this kind of stuff. So it really depends on the problem you're trying to solve and the nature of it. But at least knowing with your different OSPF area types what your options might be helps maybe with a problem like that. Or maybe you're just the super hyper controlling network engineer we've talked about before. And just I want to summarize routes on an area with my perfect IP addressing plan that I carefully carved in my spreadsheet so that this area is only going to have these IP blocks in it that I can summarize to this one announcement. And if you want to do a summarization, you've got to do it on an area border router too. That's yet another
that I
challenge
understand.
Here. Yeah, right.
That makes me happy.
All us OCD people are like, yes. So do you want the additional design complexity so that you can look at your routing table in area 0 and go, it's perfect. I summarized all the things. And when it was really, does it change your network functionality at all? Does it accomplish anything super critical other than satisfying your OCD desires? We could argue about that. Yes, no, maybe. I don't know. Okay, we gotta keep talking about OSPF area types and start talking about OSPF area types. So a few things to remember. I think we gotta talk through before we talk about the different types themselves. For people that are not OSPF nerds, let's define some things. So I'm going to make a statement. And you tell me if you agree or disagree. 1, an OSPF area is made up of 1 or more routers. Does that sound right?
Yes.
Yes. It's not a trick question. I'm not trying to mess with you.
Well, I'm just trying to think. It's more so, how often do you have an area with only 1 router, is my...
Not often.
Yeah.
I mean, pretty rare. Like if you say you had an OSPF network and then you had a single area 0 router, like in some funky WAN design, you got some head end router that's your area 0 and everybody else hangs off of that and is in a different area. I mean, ew, because as soon as that router goes down, I mean, that's just a horrible design. That's terrible. No one would do that in production unless they were incredibly budget constrained and Android just had no idea what they were doing. So is it possible? Yeah, it's possible to have, but I would say the backbone area, I would say it's going to be a non-backbone area router. You might have just a single router might be in area 0. Again, that small office scenario, the Soho router, perhaps, it's an area 1 and it's the only router in area 1. And that's it. And it's an ABR with its WAN interface in area 0, perhaps. And that would be a way to do it. And then you're summarizing into the core area 0 from there. And they're just not any other routers in that office because you just got the one, so you can get in and out of the office. So that's why I said 1 or more routers. Yeah. All right. Next statement. OSPF multi-area looks like a hub and spoke design. Area 0 is the backbone area, aka the hub. Does that sound right to you?
Yep, a picture I can see.
Okay. So then all other OSPF areas hang off of area 0.
Yeah.
You agree with that? Yep.
Yes. So they all have to go through area 0.
Now this bit's important, and again, people that don't know OSPF, the rules of OSPF, if you will, might be like, oh, I could have area 0, and then next I could have area 1, and then I could daisy chain off of area 1, area 2. No, you can't. That's not how that works. You would have to, if you have 3 areas like that, area 0, your backbone area, and then area 1 and area 2. Area 1 hangs off of area 0, area 2 hangs off of area 0, and area 1, area 2 need to talk to each other. They got to go through area 0 to make that happen. That's how that works. Those are the rules of OSPF. And the answer as to why it works that way is loop prevention, and that's would be a whole other show. But that is why that is why that happens. So, for example, you could put a link in between OSPF, the router, and OSPF area 1 and the router and OSPF area 2. We could put a link in between them, but traffic's not going to flow there.
No.
I actually started messing with this in the lab. It gets weird. It's just like it'll let you do it. You can. It's just weird. It doesn't work like you think it's going to work. Like, oh, area 2 will start talking to area 1 directly, and vice versa. Yeah, no, that's not. Nope, does not. That's not. It's not a backup link. It doesn't do the thing you think. And again, OSPF rules. All right, we talked about this. I just want you to sanity check this statement. An OSPF router with an interface in area 0 and an interface in another area is an area border router, ABR.
Yep.
Okay.
It's the border of the area.
It is. Nothing complicated there. But yep, it's an area border router. And then an OSPF router with an interface in any area that is also redistributing non-OSPF routes into OSPF is an autonomous system, there's that word again, boundary router, an ASBR. You comfortable with this, even though if you don't like it?
Yeah, so it's any router that's pretty much connecting your OSPF bubble, because I'm not going to use the word AS, your OSPF bubble to everything else.
Mm-hmm. Yep. Maybe you've got a BGP router that connects you to the rest of the internet, and so you are redistributing BGP routes into OSPF there. That would be an autonomous system boundary router, and you can do that in area 0 or a bunch of other area numbers. There's no rule on which area it's in. There are some concerns about the area type an autonomous system boundary router is in. And then finally, an OSPF router with interfaces in a single area only area 0, only area 1, whatever it is called an internal router.
Yes, indeed.
Yes?
There's a lot of OSPF specific jargon that comes.
Yeah, and that's why I wanted to run it by. See, like, you've heard this before. Yeah. This sounds right to your ear. It jives with the training you've been going through as you've been working on this stuff. This all lines up.
Yep, I've got all the acronyms and all of the expansions of the acronyms written down somewhere.
Okay. So now let's get into the OSPF area types themselves. Folks, it was only 30 minutes, 28 and a half minutes. Come on, don't be babies. We got there. We got to our different OSPF area types now. And the first and most important one is what, Holly?
Can I ask a question before we dive into them?
Yes, sure.
We haven't even discussed them, and I'm already like, but hold on. Okay, so because I'd like to clarify this before we go into the specific types, and it's something that maybe also confuses my brain a little bit. So we're going to discuss OSPF area types, right? But we also refer to areas, for example, area 0 is the backbone area, area 1, area 2, and so on. Now, when you're giving an area a number, in, let's say, area 1, is that going to be a specific area type as well? So, like, we've got area 0, that's the backbone. Area 1 is one of the types.
As far as the numbering of OSPF areas, area 0 is the only unique one. That's uniquely defined as the backbone area. All the other numbers are whatever you want to call them. If I remember right, it's a 32-bit binary number. that you can represent either as decimal, like area 1.
Yeah.
Or you can represent it as dotted quad, like look like an IP address, and you can represent the area number that way. But there's no significance to the number other than it's a number. The area
So
type is something you define in a statement,
yes,
or as part of the statement when you create the area.
and that will just have a area number. Like you're not gonna, I guess it's like you're not gonna have different types of areas in a area number.
No.
Yeah. Okay.
No. The area number and type is got to be uniform throughout the OSPF network. The bubble, as you put it. That is, if on one router you were to create area 1 and declare it to be a stub area, and then on a different router you create area 1 and say it's a totally stubby area, and then try to connect 2 interfaces on those guys.
Yeah, not gonna happen.
It's not gonna work. They're gonna go, these are different area types. We've got the right area numbers, but they're different area types. I can't do this. I can't. And it cries. There's smoke might come out of the back of the router. I mean, it's very dramatic. Okay.
Okay, now we can discuss area types. I'm done.
So then the first and most important type is what?
The backbone area, area 0.
Yep. It is special, this type. It is traffic between non-zero areas that are not numbered 0, have to traverse this area. So the backbone area is a special network in that sense. It is also, the backbone area behaves as a quote-unquote standard area. And so standard area is another type, and a standard area type would be just any regular old OSPF area that isn't the backbone area. So again, not to confuse those, the backbone area is area 0.
You don't really hear of the standard area that much, actually.
Not really, no. But that is the reality of it. I mean, it's the standard area is, again, it's just not the backbone area. So you don't you haven't made it one of the other types. You haven't made it a stub, a totally stub, a not so stubby area, or a totally not so stubby area. So let's walk through these, and then we can map through LSA types if you want, because you had a nice chart you pasted in here about. At least I think that was you. Was that me?
Yeah. No, that was me trying to find a pretty picture so I could visualize the differences between all these similar named areas.
Yeah, I didn't want to. It's funny. There's a few different ways we could walk through the different area types, and most instruction, I think, maps the LSA types, that is the type of link state advertisements you might see because of a specific area type, to the area type, and then make that like the differentiating characteristic. It's like, well, yeah, but that's a result of it. It's not like the point of it. If you understand the point of the area, or what its defining characteristics are, then I think the LSA types make more sense. So in the initial explanation here, I kind of wanted to leave LSA types just out of it.
100%.
Then, we can add LSA types to it rather than all at once go, this is a backbone area, it's got LSA types 1 and 2, and wait, what are we talking about LSA types? We don't have to worry about that yet. We'll get there, and it'll make more sense in a second.
And I think that's what I'd like to get out of this episode. If you're a listener, you and me are probably on the same page. Like, I want to understand, why do we have a stub area? What is the function of it? Like LSA types, whatever. But, I think, like you said, once you have that fundamental understanding of, oh, okay, this is actually why I want this, and this is its purpose, then like everything else falls into play.
So you just said stub area, and that's next on the list. So perfect. Do you have a sense of what? Forget about OSPF for a minute. Do you just have a sense of stub areas, or the term stub in routing broadly?
Somewhat. I think how I interpret this is that if you think of what a stub is, I kind of think of it as like an endpoint, or like you don't really have anywhere else to go. Yep. Like a cul-de-sac of an area.
Yep.
If that.
Yeah, I think those are all good.
Yeah.
Those are all good analogies. In routing, generally, a stub means like this is the end. There's nowhere else to go. There's no external links in a stub area. Just you're talking about let's talk about OSPF here.
Yes.
Another thing to think about, it's not a transit area. I'm not flowing through this area to get to something else outside of the area. You can assume the only way in or out of an OSPF stub area is via area 0. That's it.
So this, I think, is where it kind of confuses me, right? Because you're saying, okay, a stub, the only way in and out is through area 0, but is that not true for all areas other than the backbone?
Autonomous system boundary routers.
Okay, besides those guys. Okay.
Well,
I see.
This
Okay.
This is going to be the key to understanding our not so stubbies and these other types coming up. ASBRs are going to come into play here. We'll build on this. We'll build on this. At the moment, let's just trust.
My brain is just like, and what about this? And what about this? I'm like, okay, let's slow down.
If you get the concept of a stub area, the rest of these make a lot more sense as we build on them. So stub area is the base. So in an OSPF stub area, you're going to share information about other OSPF networks in the OSPF domain, but not about routes from other routing domains injected into the OSPF domain. External routes, ASBR kind of routes, for example. Well, how would the stub areas get to those other routes, you might wonder? And the answer is because it doesn't know about them, right? It's a stub area that isn't allowed to know about those other routes. How would it figure that out? Default routes. A default route is going to be injected into the stub area. Hey, stub area, you're a dead end. You can't get anywhere except through me. So you know what? I'm not even going to tell you about that stuff. I'm just going to send you a default route, and that default route is going to handle all the stuff I didn't tell you about. Basically, that's it. And again, going back to our earlier part of this conversation, if the only way in and out of an area is via this link to area 0, why does it need to know all this other stuff? And so then the question goes, well, wait a minute. A stub area doesn't advertise external routes. There's no external routes that are advertised into that stub area, and they're covered by a default route. But what? Do I even need the internal OSPF routes? Well, maybe you don't. And in that case, you can say, I don't want just a stub area. I want a totally stubby area. The only thing I'm going to announce from area 0 into the totally stubby area is a default route. That's it. You're totally stubby. I'm not telling you anything. I'm just giving you a default route. You send everything to me, and I'm going to take care of it for you. Because why do you need to know? You don't actually need to know. Maybe.
Okay, so a stub area has visibility into other internal OSPF routes, no external routes. Totally stubby only has the default route, nothing else. Doesn't know what's happening in the other OSPF areas, doesn't know about external anything. It's just like, this is my path out, and that's all I know. After that, it's a mystery. Okay, got it.
Now, why? Why do we have these two different types?
It's a good question.
Imagine you're at a remote office and you've got one OSPF router that is the connection between that remote office and some kind of a headquarters. Do I need a stub area or a totally stub? Which of the two area types would be most efficient in that scenario?
I mean, I guess if you've got a remote office, I just make it totally stubby, but I don't know if that's correct. But because why does it just need to know what's happening in HQ?
If I've only got one router and it's the only way to go, exactly. Why do I need to even advertise internal routes? Totally stubby would work, right? Just send a default route up there. It'll figure out its own internal stuff, and if it can't figure that out, it ends up at that WAN router that's at the edge. The default route covers everything else, and it sends it out to headquarters. Now change the scenario. It's the same remote office there, but now I've got two OSPF routers at the edge. Stub area or totally stubby? Which might work?
Stub area. But why? I don't know why. But I mean, it depends. Because if you've got two, then you might have some sort of load balancing or something else. And you might not
Mhm.
want them both on the exact same. So if you've just got one default route, do you
Yeah,
need
if I've
to?
got two links,
Mm,
then I have, and I know about my OSPF internal routes that are being announced to me from Area 0, it might turn out, based on my SPF calculations, that I can go out edge router 1 to
mm,
headquarters because it's faster for these different networks, but edge router 2 is faster for these other networks.
yep.
If the only thing I'm getting is a default route, and assuming my bandwidth is the same across the two links, I'm just doing equal cost multipath across
Mm-hmm.
both links because I'm too ignorant. I have abstracted the detail of the routing tables away and hidden it all behind the biggest summarization route of all of them, a default route. I don't have enough information to do SPF calculations to
Mm-hmm.
determine what's the best way out of the area to get to these various OSPF destinations. Stub area means I haven't masked all of that information away. Totally stub area, I have, and the use case is I got one router that's only one way in or out. It just doesn't. I don't
Yeah.
need to tell you because all you need to know is default route. That's nothing changes if I were to give you all the routes versus a default route. Nothing would change. So I'm just going to give you default route and keep it simple. Stub area, totally stubby area. Yeah.
Got it. Yes.
Okay. So now this next part of the conversation should go easier. You just shook your head no. What did you shake your head no about? Because you know we're going to talk about not so stubby areas?
It's my least favorite. Let's proceed. I'm not going to complain. I'm open-minded.
Okay.
Like, why would you call it that? Because, like,
these are guys in the IETF who are engineers. They're not artists. They're not
like,
going to come up with something super creative.
like,
It's who
just,
we are. We're not good at that.
like, not so stubby. Come
These are
on.
the same kind of people who are going to name their server farms after the Lord of the Rings or Star Wars. It's who we are. I have done this. I am guilty of this. I'm not good at creative names. Not so stubby. It does make sense. It does. It does.
Okay.
So let's explain why it's
Fine.
not so stubby. So a not so stubby area in NSSA, it's similar as a stub area, right? It's very, very much the same. But you need to import external routes from another routing domain into it, the ASBR. You need to have an autonomous system boundary router in this particular area. If it's a stub router, you can't do that. Or if it's a stub area, you can't do that. If it's a not so stubby area, you can. So it is stubby, but it's not so stubby. It's not as stubby as the stub area, you see. You just you get it.
I mean, like, I get it, but it's like, you could have just been like, oh, it's a, like, I don't know, external stub area or something.
Mm-hmm.
They're all stub areas in theory. They I'll think about it and get back to you. But they technically, like, you taking one name, you naming all of them, be like, yeah, they're all stub areas, but like some are more stubby than others. This is less stubby. Like, I get it. I understand.
I'm with you.
But it
the descriptors are
me.
not strong. Descriptors are not strong. However, they have been codified for a long time. They're not changing.
I'm just not using them.
So NSSA, it's just like the stub area we talked about, but you need to import those external routes from another routing domain into it. So you got that autonomous system boundary router function hanging off of this area. And a default route is not going to be injected into an NSSA from Area 0. You're not going to inject a default route unless you specifically configure it to.
Okay, so I have a not so stubby area, NSSA. I don't, whatever the use case is, the specific area doesn't care about actually what's happening in my OSPF autonomous system. It actually cares about what's happening outside of it. So it's like, whatever.
Well, it cares about both.
Okay. But it's not getting a default. Is it getting the internal OSPF routes? Yes. Because it's a stub area at first. So it's got internal OSPF routes.
Routes, yeah.
And the external routes from the ABR.
From the ASBR.
ASBR.
Yep.
And that's it.
We're not so we're not injecting a default route automatically. If,
Yes.
as an engineer, we choose to inject a
Mm-hmm.
default route into the not so stubby area, we can do that, but it won't happen automatically. Why? What is the logical reason you would not send a default route into a not so stubby area?
I don't understand why we need a not so stubby area. So I'm like, no, genuinely, I can't visualize, or I can't like piece together the use case of why I'd want.
It would be a topological problem. That is,
Okay.
the way your OSPF network that pre-exists whatever this new circumstance is, it so happens that you're in a situation where you've got an area and that's the place it just so happens you need to redistribute BGP routes or whatever it is. You've got to
Okay.
inject external routes in there for some reason. And you're stuck. You're like, oh, had I known this was going to happen, I might have done this a different way.
Mm-hmm.
Or maybe you would have preferred to put your external route redistribution into area 0 or whatever. But whatever the circumstances are, and there's some very, maybe people in the historically here can talk through their history with not so stubby areas. Like, oh yeah, I always used NSSAs because reasons, whatever their reasons were. Or they did, could be, I'm thinking out loud here because I have never had this problem specifically myself, but it could be you have a not so stubby area, you accept external routes at your ASBR and then at the ABR of that area, before you announce them into OSPF, maybe you summarize them. You could do that depending on the nature of it. I'm talking about BGP as an example, and maybe some internet routes, but it more commonly some other network that's merged into yours now, and that's the connecting point, happens to be whatever this area that's this non-backbone area is. You're like, not so stubby area. That's the way I gotta go. And I'm going to summarize the routes that are coming in from this new company we just merged with, or we acquired, or were acquired by, something like that. So I can think of different, and this goes into the, I was saying at the beginning, have an open mind. You were going to run into problems with network design where you're like, well, crap, I never would have designed it like this. This blows. I have to solve the problem in whatever way, and knowing all the different pieces that you have that you could bring into play to solve the problem are really handy. So it could be you're faced with some weird network engineering challenge someday. It's like, okay, Holly, we got to bring this network into this network and connect them, and you can't change anything. And we're not going to give you any new equipment. We're not going to do anything, but you got to bring these together. And we've got these security requirements, and we need this, and we've got this overlapping IP subnet problem. So to merge these two networks, how are we going to do it? And it could turn out that the answer is not so stubby area with OSPF or something. You'd be like, didn't see that coming, but it happens to be an important piece of the puzzle that helps you accomplish, from a network engineering perspective, what you need. That's the weird thing about network engineering. You're like, I'm never going to need this until you're in that weird situation, and you're like, oh crap, how do I do that? So nerd knobs, if you look at any Juniper Cisco Arista box, and you start hitting the question mark or the autocomplete and see all the different commands and tags and options there are, why are most of those there? Because someone had a problem one day and are like, man, if only I could tweak things just like this, it would really make my life better. That's why all that stuff exists by and large. Not so stubby areas, maybe that, there is some network engineering challenges are solving for somebody. So back to the question we haven't really yet answered about not so stubby areas. The default route is not injected unless you configure it to. Why?
Well, I guess now you've got external routes as well being injected there. So maybe you don't want a default route when you have those external routes as well. Something like that.
Maybe. And maybe even the default route is coming in from those external routes. That could be too. All depending on the nature of what this external domain is, this external autonomous system. is that you're you're bringing in. It could be the default route's coming from there, and so you don't want a default route coming in from the core, from area
Yeah.
0, and then SPF calculations have to determine, do I use this area, this area? It just could be that the default route that you want actually originates from that external domain. That was my thinking anyway, as far as why. That's the first thing that leaped into my head. There may be other reasons too. And if you've got some well actuallys to explain why, please send them in. We'll share in a future episode. Okay, so the last area then, before we talk about LSA types, if you even want to talk about LSA types at this point, if you're just not mad at me, but we would be the totally not so stubby area. And what? Go ahead.
Carry on.
Go ahead.
No.
Go ahead. No. You shaking your head? No.
I can't complain about it. Like, this is like it's totally not so stubby.
But it's totally not so stubby in the same way that a stub area and a totally stubby area are different. A not so stubby area and a totally not so stubby area are different in the same way.
Okay.
So what was the difference between a stubby area and a totally stubby area?
The view, not the view, but exporting or importing those internal OSPF routes into the area.
In a totally stubby area, that doesn't happen. The internal OSPF routes don't get sent into the stub area. In a totally stubby area, it's just a default route. With a not so stubby area, you would get the internal routes, but with a totally not so stubby area, you don't. It's basically the same thing. The
so that would have
is totally
just the external routes. And what about the default? Because by default, you're not putting in a default route in a not so stubby area. But if it's totally not so stubby, then is it still like, oh, maybe I'll have a default route? Or is it just no default route, it's just the external route?
I didn't write that down in my notes. That's a good question. Let's see if I can find the answer to that super quick, or you can. We can both use search really fast.
I'm trying to think about it like logically.
Well, I am too, and I'm going, wouldn't you want to, I would assume not, right? And not so stubby area would have the same behavior.
Yeah. Because a totally stubby area has the default route. So if you have a totally not so stubby area and it only has external routes, then that's the only place it can go.
Yeah, no, a totally not so stubby area does receive a default route from what I'm showing. Yeah.
Because that would make sense, because otherwise we're like, sure, but if that external route is not, I don't know, it doesn't know how to get there, so you need that default route.
Yeah.
Something like that.
But that does clobber my logic of, well, maybe you don't want a default route injected in your not so stubby area because the default route is originating from the external autonomous system. I was thinking that was the logic, and that logic would still apply to a totally not so stubby area, but not the case. So maybe my logic is flawed there. If you got a well actually about that, because you've been here before, you remember from decades past why you would or wouldn't have used these particular areas and how you tweaked them and what your top topologies were. I'd love to hear about your topologies if you can, whatever you can say. That'd be fun. We could talk about that. But yeah, no, it does. I'm going to actually write this in my notes. Does get a default route. Okay, there we go.
Okay. I hate them less.
Do they make more sense?
They make a lot more sense. I think that you look at these things out of a textbook and it's like, this is a stub area and this is a totally stubby area, and like you never actually, or maybe I didn't, let me not generalize the greater population. I didn't sit down and think, okay, well, number one, why do I need any of these? And number two, like, okay, well, sure, they've got these silly names, but what does that actually mean? And I've never thought, oh, well, a totally stubby area and a totally not so stubby area, well, that totally actually is similar in both cases. Like, is it very descriptive? Maybe not, but like, if you look at them as a whole and all four of them together, they're all similar. They're all very similar, but all also like have very key differences, but those key differences like differ between, like, I'd say the two groups. So like stubby and then like the not so stubby ones.
So you had copied into our notes this awesome little matrix of LSA types and backbone areas. Do you want to
Mhm.
walk us through the LSA types real quick? Do we
Um,
think that's important?
and now that I understand the areas, no, I don't actually, because if you understand the function, then you automatically will know once you learn LSAs, you'll understand, oh, well, obviously, well, type 7 LSA is only for not so stubby, so you're not going to see that anywhere else.
Yep.
Or maybe, I don't know, some don't have ASBRs, so you're not going to have a type 4 LSA, which is for ASBRs, because those areas don't have them. So
Mhm.
I'm going on a ramble here, but explaining things, that wasn't my intention. But like, it's,
No, you're allowed to mansplain things. Absolutely. It makes me feel way better.
but no, I feel it's quite a, I learned about this I was looking at LSAs in my JNCIP training, and then the areas were like a afterthought. Now we've done areas first. I'm like, okay, now I don't have to go and learn all 7 types of OSPF LSAs, because it's a much more logical thought process of, well,
Well,
actually understanding what's going on.
you still do need, from like for an exam and certification
Oh yeah,
perspective, you do need to know how to put these things together, though. I will say that.
but you
And
can if
there's
you have
there
the
is some
understanding.
oddities, like the type 5,
Hmm.
type 7 to type 5 LSA conversions, for example, that happen with not so stub areas.
But that makes
Uh,
sense, because if you think about it, right? No one else, like your not so stubby routes or LSAs
mhm.
types, are never going to go into another not so stubby area. So if a not so stubby area is the only one that knows about this type 7 LSA, because it's a not so stubby area, someone else isn't going to understand that. So you're going to have to translate it into something that's
Which
comprehensible
happens
by a
at the
different area.
ABR.
Yeah.
They turn at the ABR. They get turned into a type 5 before they get announced into area 0. Yeah,
Yeah.
exactly. No, and so the fact that you're making sense out of this and mapping them all together is great, and that is so important for network
Mm.
engineering, to get this stuff in your head. Trying to memorize all the facts and the figures and RFC numbers and bits and bytes and headers and fields, and it just, you get lost and mired down in the detail until you can put some context around it, which
Mm-hmm.
to me is why labbing is so important too. Spending time with it in the lab, trying things and having things not work is such a huge learning tool. It's like, you want to, my favorite thing to ask people to do in a lab is go break things. Keep trying stuff until it doesn't work, and then figure out, why didn't that work? And if the only answer is, well, you're not supposed to do that, you probably missed the point. There's a point in there somewhere for why it doesn't work that way. All of these standards and tools and protocols came about from experienced network engineers banging things together in the IETF, the Internet Engineering Task Force, and coming up with a solution that works because they tried stuff and it didn't work, or they tried stuff and they had this problem, or it was okay, and then after they added that 101st router, it didn't work anymore because they had a scaling problem, and so they went back to the drawing board, and these standards have emerged over time. There's a why.
Mm-hmm.
Almost always there's a why. And if you understand the why, and that whole thing I just watched you go through, where you were like, it's like, I care about the LSA types, but I kind of don't care in a sense, because it just makes sense now, because I understand the
Yeah.
point of it. And of course, LSA types are going to function in a particular way because they have to, based on what these area types are. Yeah. When you get to that level of understanding, I mean, you still got to spend time and really make sure you get it. But now you've transcended the facts and figures, and you can look at that obtuse, annoyingly phrased question that they ask you
Yeah.
on the exam and be like, I know what they're getting at. They're talking about the, whatever the thing is. You kind of get the point they're really getting at, to see if you understand it. And it's not B, it is definitely C, even though those are almost the same answer. It's definitely, that's how
And
you
I
get there.
didn't have that. Like before this conversation, I did all the modules, I've gone through all the stuff. I know the LSA types, I know a little bit about OSPF areas, but like that logic or that like thought process that I've just got into at the end of this episode has like totally changed the way that I can now approach an exam, because I'm not approaching an exam with, oh, I just ingested all this information, I can answer the questions. I'm like, oh, I actually understand like why we doing things and like how this applies, and like that's wonderful. But like that was my goal of doing the JNCIP. Like my goal is not to pass the exam. My goal is to like have these conversations and be like, oh, obviously it's an LSA like type 7 that's going to be a type 5. Hello, you know.
All right, you ready for some rapid fire questions?
Sure.
Close out this. This is probably the longest episode we've ever done. Okay. I'm still laughing at us because in the beginning, the whole idea of this form was like 15 minutes, super fast, boom, boom, boom. No, that's not working out.
No, and I'm just
okay.
Let's do it.
Okay, rapid fire questions, and let's bring this to the end here. You try to form an OSPF neighbor relationship with an interface that's in a different OSPF area. What happens?
Not happening.
Nope.
It's not going to work.
No, OSPF's not going to allow this. Is going to get some kind of an error. It's going to get a mismatch. What? And don't look at the notes. You're not allowed to look at the notes. I want to see what
I'm not looking.
You can logic your way through. Try. What happens if you try to configure the backbone area as a stub area or any other area type?
That logically doesn't make sense. Like it's a backbone. Everything's got to connect through it. It can't be a stub. I don't know what it will like. You'll probably get an error, I would assume.
I tried it on a router in the lab. I think it was a Cisco box, or it might have been an Arista box. I don't know, but yeah, the network operating system doesn't allow it. It's
get like a commit error.
It's a backbone area. No, yeah, it would be like a commit area in Juniper. It would be like no, assuming it even allowed you to put the command in.
Sure.
You define some OSPF routers in an area as one area type, but other routers in that same area as a different area type. What happens?
I don't think it'll be a commit issue, but like I don't think it's gonna function because again, like all those LSAs and everything else are gonna get really confused.
Yeah, it won't be a commit issue in Juniper speak. It'll allow it, but when the neighbor adjacencies try to form, they're going to fail because the area type is flagged in hello packets. It's one of the, if you look at the structure of a hello packet, there's a bunch of flags in there, and area type is one of the flags. They got to be the same, or OSPF's going to be like, yeah, no, we can't do this. Okay, you connect two non-backbone areas directly together, like area 1 and 2, and you've got one router that's got an interface in each area 1 and 2. What's going to happen?
That's what we discussed before. You can do it. It's not going to work. Everything's got to go through the backbone area. It's going to be get some funky results.
I actually tried this. I spent an afternoon on this in the lab. It is weird. LSAs do not propagate between those two areas. It's just odd. Like
That's so interesting.
You can do it, but it doesn't. Like you look at routing tables and you look at link state databases. It's just very odd, and it makes sense that it would be very odd because it's not. Those are OSPF rules. You're not supposed to be able to do that, but it doesn't stop you. Because there's legit design reasons you might have that scenario. I can imagine that scenario. But if you try to do it without area 0 involved, it's just weird. All right, you build a single area OSPF network. So we just got one area. Yep. Your favorite, Holly. Not multi-area, but single area. Yay! But you number that single area something other than area 0.
I don't know what will happen, but like to me, that area has to be area 0. Do you name it area? Like, I guess my next thing is if you've defined the backbone area, are you actually naming it explicitly area 0, or is that just default?
That is the name. That is
like, do I have to manually say?
As far as I know,
area
backbone
0
must be area 0. That is a unique requirement of the backbone area. Somebody will actually me if I'm wrong, but that is, as far as I know, that is a must.
Which is funny because then I'm not gonna. We're doing rapid fire. I'm not gonna go through this because like technically the area number doesn't really matter unless it's the backbone area.
So this becomes one of those scenarios where it's going to work fine. But what an odd thing! Like if you're a network engineer walking up on OSPF network single area and you're like, you called it area 10? Why though? That's basically your backbone area. It's area 0, so it doesn't break anything. It doesn't.
Yeah, because the area numbers don't matter. Like they don't matter in terms like what I asked earlier. Like it's not linked to a packet, or like it's not going to be like, hey, I'm not so stubby and I'm area 2. Like, good for you, area 2. Don't care. I know what type you are. So
Yeah, so it'll definitely work, but it was like I can think of 1,000 design reasons to not do that. Either just because of the expectations of other engineers, because someday you might need your network to join with another network, and if you don't have that OSPF area as area 0, it's just really complicating your life. Really, really are.
unnecessarily. Like 0 is a good number.
2 more questions. You have
Okay.
a multi-area OSPF network, and number 2 physically separate. What did I write here? And I see what I wrote. Sorry, let me rephrase that. You have a multi-area OSPF network. You
Yes.
number 2 physically separate OSPF areas with the same number. So you got
Okay.
2 different area 10s. So they
Okay.
got the same number, but they're not connected to each other.
Are they different types?
Doesn't matter for purposes of our conversation here. Or it could be, maybe you didn't design it this way, quote unquote. It could be the area got fragmented because of a network failure of some kind, or partitioned. And so now you've ended up with 2 different areas.
I would think,
what's going to happen now?
based on what I said previously, like the area number doesn't necessarily matter. So I think it will still work, but you might get some issues along the way, I would think. Because otherwise, if you don't get some issues, then there's no point of even having area numbers.
Yeah, it gets weird because all the routers in an area assume that they have an identical link state database, right?
Yeah.
But now they don't. They both have very different link state databases. And so it gets weird with, like, if they're both still connected to area 0, you can have routing failures and...
like, hey, I'm from area 1 and I'm like not so stubby, and someone else is like, but I'm also from area 1 and I'm totally stub. What?
I wouldn't. Let's assume that it's a partitioned area and they had the same area type.
Okay.
In that scenario, you'd have 2 different areas that maybe they got partitioned because of a network failure. That scenario, that's a thing that could happen. They're like, wait, we should be able to reach each other directly, intra-area routes.
Yeah.
Why am I having to go through area 0 to reach you? That doesn't make any sense. And so I think you end up with this weird routing or routing failures where the partitioned segments of the area can't talk to each other via area 0, even though there's a physical connection there.
Yeah, because I guess it's like trying to reach its internal friend that's actually not internal.
That's actually not internal because of the partition.
Yeah.
That's that's a weird one. That'd be a fun lab exercise to see what happens. And I know, this actually leads me to my last question. What happens when the backbone area is partitioned like that? So you end up with 2 area 0s now.
Well, you can't have 2 area 0s. So one of them's going to have to be not area 0.
Yeah, it's ugly. It's bad. Yeah, you've created 2 different OSPF networks now. That is functionally, that's what you've actually done. And OSPF design guides would be like, yeah, make sure this doesn't happen. You definitely don't want this to happen. So make sure it doesn't happen. This would be part of your OSPF design, which is part of why I was saying earlier, we were talking about, like, could you ever have a single router in an OSPF area and that's just have the one router for that area? And we were kicking around different scenarios, and one of them was like a single router for area 0. And it's like, oh gosh, that's, horrible.
You can, but you shouldn't.
Okay, this is a very long episode, Holly, for us. Very long. We should call it, and we should break it into 3 episodes parts. Oh boy,
Holly complaining some more. Holly actually complaining a little bit less, and she's come around, but like not too happy.
All right, everybody. Thank you for listening or watching. N is for networking. Send us your comments, your love, your well-actuallys to packetpushers.net/follow-up, or join the community Slack group at packetpushers.net/community, and tell us in the N is for networking-pod channel anything you want to say. We get lots of feedback from all of you. We love it. Send more feedback. We really do appreciate it. Like, subscribe, tell all your friends. N is for networking is climbing the ranks of the many Packet Pushers podcasts, and Holly and I want this show to be #1 eventually. So help us out by letting the world know about this show. We are everywhere you get your podcasts, including YouTube, where you can see Holly and me chatting with each other if you'd like. And until next week, just remember, networking isn't hard. Other people figured it out, so you can too.